So what is a super hexagon? So it's actually a hexagon that we can just draw like this. And it's going to be super useful for so many trigonometry formulas, because there's a lot of formulas, but with one hexagon we can just we don't have to memorize we don't know flashcards, nothing. We're just gonna be able to get all the formulas when we need. So whenever we need a trigonometry formula, we draw this hexagon, 6 sides. And what we're gonna do is we just have to remember one thing. We have to remember that tan theta is equal to sine theta divided by cosine theta. So that's kind of weird, but how can we kind of remember this too? We remember this because we see C, S, and T. So they all go in alphabetic order. So C is first, S is second, T is third. So this is also a very important one. We have to just commit this one to memory, and then we'll get 20 more formulas just by remembering this one. Okay, so what we're gonna do first, we're gonna connect all the vertices. Let me just draw a line. So we're gonna draw all of these lines, and what we're gonna do is we're gonna draw a 1 in the middle, just like this, a 1. Okay, and there's three main identities that we can get from the superhexane. Okay, why did I tell you to remember this? So C comes first, then S, then T in the alphabet, right? And C is all the way in the bottom. Okay, so we're gonna use this identity, and we're just gonna label it like this. Okay, so look, we're gonna label it tan, and then sine, and then cos or cosine. Okay, and what we're going to do from here is that we have to label all 6 vertices. The reason I'm showing you this is so we have a way of remembering what to label all 6 vertices. So I've already labeled 3. So how did I remember to label these 3? I just used this formula. Tan, tangent, sine, and cosine. So I just labeled it right here. This vertice, we always start from this vertice, okay? The most left one. So tan, sine, and then cosine, because we know this is the formula. So after we've labeled that, how do we label this? We know that cotangent is always opposite the tangent. So we're just going to label this one cotangent. And what we're going to do is to label the 5th vertice, we're going to split the hexagon in half. And we know that all the C's will be on the right. So this one begins with the letter C. This one is C. And what's the other one with C? Yep, you got it. It's cosecant. Cosecant, like that. And then the only other trigonometry function left is just secant. There you go. After you've labeled it, all the work is done. Now we can give 3 identities, and each identity will give us 6 formulas, and that's so useful. Okay, so the first one. First thing we can do is that we don't have to remember. It's called the reciprocal identity. Okay, it's called reciprocal. Reciprocal. And what this is basically saying that anything that is opposite from each other is the reciprocal. For example, tan is equal to 1 over cotangent. Tan equals 1 over cotangent. I'm not writing the thetas, but also cotangent is equal to 1 over tan. So basically, anything that's across from each other, so cosine is 1 over secant, and sine is 1 over cosecant. And this is very helpful because sometimes you cannot remember what is the opposite of sine and what is the opposite of cosecant. Just remember this hexagon, and then you will remember all the reciprocals. So the first one is the reciprocals. We can memorize all the reciprocals just like that. What's the second one? The second one is, I'm going to look here, and it's called quotient identity. So quotient. So what did we use to memorize this entire hexagon? We used a quotient identity. It's tan equals sine over cosine. Tan, sine, cosine. So how does this work? We're taking any 3. So we take any 3 that are next to each other, and the first one we choose is going to be equal to something. For example, I'm just going to take tan. And then what are the next 2? I'm going to list them like this. Sine over cosine. Okay, let's look at another example. Let's choose any three that are next to each other. Let's choose this, this, and this. So we can choose it in any order. So let's try from this order. Cosecant is equal to cotangent over cosine. You see how this one works? We're just writing it from we just choose three and we choose one of them, and then one of them will equal to this one over this one. So that's how we remember all the quotient identities. Look how many we can do. We can do cosine is equal to sine over tan, sine is equal to tan over secant, secant is equal to cosecant over cotangent, cosecant is equal to secant over tan. So many we can remember. Okay, so those are all the quotient identities. And now there's one more useful one, and we can get three of them. These are the Pythagorean ones. So the Pythagorean. And I'm just going to redraw the hexagon really quickly. And while I redraw it, hopefully you will also remember how to redraw it. So I'm going to talk while I redraw it. So we're going to draw a six-sided hexagon. And now if you remember the formula, tan equals sine over cosine. So tan goes here, sine goes here, and cosine goes here. Now we know cotangent is always opposite of tangent. Now you tell me what goes there. Yes, you're right. All the C's on the right. So this one is cosecant. Cosecant. And then the last one left is secant. Okay? Now we're going to see how we can get the Pythagorean identities. So we're going to actually want to connect all the vertices. So connect. Let's use a different color. We're going to connect with green color. We're going to connect this, and connect this. Okay, so we see we're going to focus on three triangles. The one at the top, right here, this guy, then this guy, and this guy. So what's so special about these three guys? The idea is, you remember how we put a 1 in the middle? We're going to draw the 1. Sine squared plus cosine squared is 1, so that's very useful. We're going to draw an arrow like that. Same thing for here. 1 plus cotangent squared is cosecant squared, and tan squared plus 1 is secant squared. So I'm just going to write them out. So for example, sine squared theta. Okay, let's write it where we have more space. Where do we have some space? We can write it here. Sine squared of theta plus cosine squared of theta is equal to 1 squared, but you don't have to write 1 squared. Okay. So this is the first Pythagorean identity. We also have two more just for looking at this hexagon. So this 1 plus cotangent squared is equal to cosecant squared. You know what I love about this super hexagon? There is no limitations. There is no like special case or anything. It just works for all the cases. So you know, but it doesn't work for these triangles. You know, so like these three triangles, for these three triangles. So 1 squared plus cotangent squared is equal to cosecant squared. And of course we got our last one, which is tan squared plus 1 equals secant squared. So these are the three identities, maybe like 20 formulas that we got from this really good hexagon.